Hello, crew. Today is my day, and my station is Sanitation Center. And I'm going to begin now my presentation. Yeah. Expectations from the Sanitation Unit. The first one is generated gas, energy generated from the biodigester, sewage collected, source of water type, toilet, food preparation, humidity, location which infrastructure, and source interior. And the third one, produced water, reclaimed water, able to be consumed. And continue, water received from air was quantity, source exterior, EVA ice water treatment, evaporated water and amount. And continue, stored water, air analysis and treatment, remove or add humidity, temperature control at the station, and the last one, stored air and distribution. Okay, Sanitation Center, and the first one is internal design. We already know that, but again, just I'm gonna say it. The second one, machines, technology is necessary for the operation of the installation. Possible resources to generate in situ prepare, transported from Earth. Organizational structure, positions, profiles and duties, astronaut training program. And continue, YouTube videos to train astronauts. Resources needed for 1 week, guidelines to be provided to other facilities, entire station, specific protocols, routine of the facility, protocols of safety, protocols for occupancy, entertainment. Okay, protocols for food microproduction, protocols for 3D printing, technologies and outputs that could be applied to Earth, guidelines to be applied to daily life on Earth, impact to Sustainable Development Goals, SDG, and references. And with the references, we are going to finish the presentation. Okay, entire station facade we can see here, guys, and it is the my center, Sanitation Center, and yeah, with the arrow signs. Internal design. Okay, this is the entrance floor. I think like so, it could be done. It is the entrance floor, and the all crew mainly stay here, and all the researchers, all the communication with the main station done with this floor, with these place, sorry. And interior view of the staff room. It is the second floor. It is the just like sample of the staff room. And it is the maybe the research places for the scientists or the microbiologists, maybe could be. And interior view with 3D Max sketches. And interior view of the corridor of the station. And we can use the all plans for the oxygen. And interior view of the rest area, and it's designed by Tarık Keskin, the Turkish architect, and could be like so. And the astronauts, when they have free time, they can just stay here and do some stuff. And in the presentation, in the feature page, we are gonna see it. Types of disinfection. I want to talk about a little bit about the disinfection and sanitation. And we are going to see here physical disinfection, biological disinfection, surface disinfection, chemical, electrical, and disinfection, and water filtration disinfection. Physical disinfection, the first one, what kind of disinfection we have? The first one, heat sterilization, moist heat sterilization at temperatures below 100, temperature of 100 and above 100 Celsius degree. Dry heat sterilization, red heat, flaming, incineration, infrared radiation, hot air oven, filtration, sterilization of liquids of gases, irradiation, ultraviolet, non-ionizing radiation, sound, sonic waves, pressure, pascalization, and sunlight, solar disinfection. Okay, continue. Chemical disinfection. We can use alcohol, chlorine, formaldehyde, hydrogen peroxide, orthophenylaldehyde, OPA, the important one, and peracetic acid, especially decomposition products, and nitrogen dioxide. Alcohol are not recommended for the sterilization, medical and surgical materials, principally because they lack sporicidal action and they cannot penetrate protein-rich materials. It's important. They cannot penetrate protein-rich materials. I'm talking about alcohol here. And fatal postoperative wound infections with Clostridium have occurred when alcohols were used to sterilize surgical instruments contaminated with bacterial spores. It's important also. And when we're talking about the chlorine, hypochlorite has been recommended for decontaminating blood spills because hypochlorite and other germicides are substantially inactivated in the presence of blood. Large spills of blood require that the surface be cleaned before an EPA registered disinfectant. And hydrogen peroxide is the 3% hydrogen peroxide is stable and effective disinfectant. And we can use hydrogen peroxide. And the important one is the orthophenylaldehyde, OPA. OPA appears to kill spores by blocking the spore germinate process. It has excellent stability over a wide pH range. It means 3 up to 9 pH. We can use all over the places. We can use the OPA, and it is the advantages. And it's not irritate the eyes. It's also important. And yeah, continue. Okay, there is the table of the general sanitizers talking about, and I'm not gonna read it all of them. We cannot enough time, and it's not good, but we are gonna see here carboxylic acid, chlorine dioxide, ozone, and we can use the ozone gas formed and hot water. It is the graphic is from the National Seafood LIS 2000 Sanitation Control Procedures for Processing Fish and Fishery Products. I took it, and we can use, we can see here the advantages and disadvantages of the sanitizer. And yeah. And the third one is the biological disinfection. The first one, reuse and disposal of human waste. Sweat, it goes with the air filter. Urine turns into water that is used regularly. Feces, fertilizer, and methane are obtained. Human body mortality, I mean here, it can be stored as a pure by burning, by vacuuming, by feeding it to insects or outdoors. The last one is actually in the space mission, we are not gonna have any luxury to took with us to Earth our friends, actually, the body of the friends. It is the options we can do there, but just without any religion talking, I just wrote it here, okay, the options. Please don't think about religious stuff, okay? It can be stored as a pure by burning, by vacuuming, by feeding it to insects or outdoors. This is the solution, actually. And continue, the second one, reuse and disposal of human waste, vehicle and EVA suit. Sweat and urine, they go with the air filter and air absorbed by pads with water retention, and feces solidified and stored. Okay, and fourth, electrical disinfection. In many cases, cleaning by an effective dry process would be preferable to cleaning by an equally effective wet process. Surfaces can be cleaned with low current, or current can be given to kill living things. We can use for that. And surface disinfection. For metal surfaces, alcohol, formaldehyde, and hydrogen peroxide we can use. For painted surfaces, UV and ozone spray. And for atmosphere, air particles are filtered by HEPA and membrane filters according to pore size, of course. And surface disinfection, okay. And we are talking about here the HEPA filters. It is the best and the important one. Filters meeting the HEPA standard must satisfy certain levels of efficiency. Common standards require that a HEPA air filter must remove from the air that passes through at least 99.95% of particles whose diameter is equal to 0.3 micrometer, with the filtration efficiency increasing for particle diameters both less than and greater than 0.3 micrometer. Okay, and HEPA filters capture pollen, dirt, dust, moisture, bacteria, virus, and submicron liquid aerosol also. And some microorganisms, for example, Aspergillus niger, Penicillium citrinium, Staphylococcus epidermidis, and Bacillus subtilis are captured by Hepa filters with photocatalytic oxidation. Hepa is also able to capture some viruses and bacteria. And we see here the process of the filtration. It is a filter frame and filter sheet of randomly arranged fibers, interception, impact, and diffusion we see. And this is the aluminum separator. Okay, voltafiltration. Voltafiltration is the process of removing or reducing the concentration of particulate matter, including suspended particles, parasites, bacteria, algae, viruses, fungi, as well as other undesirable chemical and biological contaminants from contaminated water to produce safe and clean water for a specific purpose, such as drinking, medical, and pharmaceutical applications. And in the first step, we have all of them, bacteria, algae, plankton, we all of them, but with the microfiltration, and then ultrafiltration, we use 0.1 micrometer viruses and protein. We can eliminate, and then nanofiltration. We can eliminate small molecules, and then reverse osmosis. And we have here just ions, all of the after the filtration process. Okay. And the second one, machines, technologies necessary for the operation of the installation. Systems to move and breathe, powerful propulsion systems to get us there and home quicker, the ability to hold off the heat, high-tech Martian spacesuits, Martian home and lab on wheels, uninterrupted POA, radiation protection, constant high data rate, communication and navigation. Stations should be equipped with advanced environmental control and life support systems designed for the demands of a deep space mission. Removal of CO2 and humidity is important to ensure air remains safe for the crew breathing, and water condensation on the vehicle hardware is controlled to prevent water intrusion into sensitive equipment or corrosion on the primary pressure structure. Okay, this is the, for example, for the scientist lab we can talk about here. This is the exhaust HEPA filter, blower, supply HEPA filter, lights we see here, high velocity air barrier, outside safety glass view screen. This is the place, just example for the scientist. A closer look at a HEPA filter. The first one is the Hepa Medya aluminum separator. The second one here, aluminum separator. Sealed ends of the media pack, the third one, and sealed sides of the media pack, the fourth one, here, the gold one, and the gas cube and the fourth one here. Okay, HEPA is acronym for the high efficiency particulate air. It can remove at least 99.97% of dust, pollen, mold, bacteria, and any airborne particles with a size of 0.3 micrometers. Okay, this is the Airlock place. Research is NASA Johnson Space Center. It is the Airlock training, actually, of the astronaut, and Airlock Disinfection Units. It is the entrance. Possible resources to generate in situ or transported from Earth. Almost everything actually transported from Earth, but I'm gonna talk about the water production at the space station. On the space shuttle, water is produced as a byproduct from also fuel cells. The process is complicated, but simply put fuel cells like electricity and hydrogen and oxygen are combined. When the atoms combine, they not only make electricity, but water as well. This water can be recycled and used by the astronauts. Because electrical power for the ISS is generated from the solar panels rather than from fuel cells, no water is produced. Small amount of water are recycled from cabin air on board the ISS. Organizational structure. Station work team. There is a hierarchical order within the team. Everyone obeys the chain of the commands, of course. Manager of the center, she or he is the main manager of the station. Microbiologist, maybe the scientist, as a scientist. supervises the life support unit with engineers. Visiting assistant checks equipment is working properly and reports to basis or the manager of the centers. Positions, profiles, and duties. Okay, we are going to see here with details, of course. Duties of the team members, manager of the center, must have an educational background in one of the fields of biology, biotechnology, or biosystems engineering could be. She or he must be someone who can make snap decisions, carry out activities, and work under pressure. Should keep all facilities running, of course. And as a scientist, maybe microbiologist we can consider, and carries out specific laboratory research and supports life support system activities, perform data analysis. I mean here with support the technician and the engineering station, I mean here. We support to them with the life support system. Visiting assistant generally monitors all work within the station, prepares reports of daily data. She or he assists her superiors in EVA duties, of course. And astronaut training program, I have here some videos. I think in this part I have video. It's gonna take like 2 minutes, not too much. Not after that. Most important step of the training, actually in the sanitation center, the important training is the airlock training for astronauts. With each lungful of air, our bodies absorb oxygen and exhale waste product molecules such as carbon dioxide, and the important signaling molecule, nitric oxide. The airway monitoring experiments looks at the amount of nitric oxide the astronaut expelled by the astronaut in the airlock. Training inside of the airlock. This is the entrance, like a torpedo tube, you can see here. This airlock in the Japanese lab, it's from the Japanese lab, allows us to put experiments out into the vacuum of space. 7 YouTube videos to train astronauts. So this part, I had 2 videos I added to my presentation. The first one like 2 minutes, the other one, second one is just 1 minute. I hope we can just watch right now. Normally it should be begin. Why? It doesn't begin. Just 1 second. journey to Mars. We hope so. I don't know why it's and this is the second one. This is just 1 minute. It's from ESA. Yeah. Exit again. Yeah. Research is needed for 1 minute, the 8th part. Photos of space menu, we can see here some real photo from the ISS. Have you ever wondered if astronauts get bored of their space menu? I think they have no such a chance or luxury, unfortunately, in the space. Consumption amount. Food aboard space shuttle served on a tray, not the use of magnet springs and Velcro to hold the cutlery and food packets to the tray. When astronauts travel into space, NASA scientists determine how much food will be needed for each mission. For example, an astronaut on the ISS uses about 1.83 pounds of food per meal each day. About 0.27 pounds of his weight is packaging material. Longer duration missions will be require much more food, of course. A trip to Mars and back, for instance, may take more than 3 years and require the provision of thousands of kilograms of food. We are talking about here, thousands of kilograms of food, guys. A crew of 4 on a 3-year Martian mission eating only 3 meals each day would need to carry more than 24,000 pounds of food. Yeah, it is a resource I already right there. Shuttle astronauts work with nutritionists to select menus that appeal to their individual tastes. 5 months before flight, menus are selected and analyzed for nutritional content by the shuttle dietitian. Foods are tested to see how they will react in a reduced gravity environments. Yeah, and meal times and the amount of food consumed are closely monitored because astronauts often report not feeling hungry in space. Caloric requirements are determined using a basal energy expenditure BEE formula. The astronauts limit water used to only about 3 gallons. It means 11 liters per day they consume. And this is the package of the beef, a package of beef with vegetables in the spoon bowl pack, scheduled to be carried on Apollo 11 lunar landing mission circa 1969. It's like 40 years ago. No, 50, sorry. Guidelines to be provided to other facilities, entire station. A message from the habitat, this message from the habitat to us, to crew. The teams of a station must complete complete with all the rules and protocols specified. Managing the project is the responsibility of the station chiefs, and schedule must be made at least 1 week in advance. All stations must follow sanitation protocols. Deploying and working together in space requires multidisciplinary skills. All stations should be in constant interactions with each other and provide regular reports to each other, of course. And specific protocols, routine of the facility, and protocols of safety. Sanitation alarm levels, we have 3 levels here: high risk, medium, and low one. High risk is meteorfall, high UV, and solar flare, contamination in the airlock, chemical, biological contamination in one of the living areas. Living areas are in complaint isolation. Crew must wear full protective clothing and go to safe section, of course. And the medium risk, possible red alert preparation phase before the experiment, local contamination that doesn't require complete closure, production fluctuation in oxygen generator, carbon dioxide filter change, nominal filtration value change, short-term and periodic maintenance services, and staff in ILA suits. And the low risk, they are ever return vehicle and personal airlock operations, no protective clothing required indoors, in accordance with the normal course of internal biological life, and no CBRN contamination, and values are nominal, and the staff is in casual clothes. This is the low risk period. And protocol for occupancy and entertainment. How should astronauts use their free time? Yeah, entertainment. Their environment puts them under a certain psychological and physical pressure. They have to find ways to somehow overcome this. Everyone's interests differ from each other, of course, and they could be photography. They're interested in photography or digital book reading, regular exercises, journaling, intelligence games, chat with team members, playing a musical instrument such as, etc. And 13, protocols for food microproduction. The 10 principles of sanitary protocols are: cleanable to a microbiological level, made of compatible materials, accessible for inspection, maintenance, cleaning, and sanitation. No product or liquid collection, hollow areas hermetically sealed, no niches, sanitary operational performance, hygienic design of maintenance enclosures, hygienic compatibility with other plant systems, validate cleaning and sanitizing protocols. Yeah, HACCP, hazard, analysis, critical, control, and points. 14, protocols for 3D printing. The first one is my research, additive manufacturing at Medya. The first one, raw material identification, pre-printing design and measurement, post-printing measurement, design and measurement for post-machining, and final measurement and testing. It is the protocol for 3D printing. And what can we produce with a 3D printer? We can produce centrifuge, mini chess, acoustic guitar, camera lens, planters, cable holder, coffee maker, camera slider, telescope, robot, drone, robot arm. Yeah, we can use approximately all of them in also ISS. 15, technologies and outputs that could be applied to Earth. I have not 10, sorry, it's 4. 4-way NASA technology already keep Earth clean and healthy. The first one, safer, powerful battery pack. Fueling planes with electricity could reduce air pollution from air travel, but getting enough battery power for takeoff is a challenge. NASA research helped produce a safer, powerful battery pack by Aerospace Sunflyer, one of the first viable power sources for all electric passenger flight, credited by Aerospace. And the second one, the development of the winglets. The development of the winglet made airplanes much more efficient, reducing operating costs and carbon dioxide emissions, of course. And after NASA readiness flight test with a KC-135, the design soon become common across the air industry. This helps like this way. And credit, of course, to NASA. And the third one, yeah, for space technologies, we continue. And the third one, Verdigris technologies. When AMES wanted to make sure its sustainability base was the most energy efficient federal building in the country. And its engineers teamed up with a number of companies, including Verdigris Technologies, to make it so. Verdigris system detects power usage across the building's entire grid, monitoring consumption device by device. Among other benefits, the system can detect any abnormal energy use, alerting users to the need for a repair and saving money in electricity costs. Verdigris customers for the technology now include major hotels, corporate offices, hospitals, and manufacturers. And the last one, observatory. Monitoring carbon dioxide in our atmosphere is a critical priority for NASA's Earth observation satellites. Looking down from orbit, these satellites detect large-scale changes in the atmosphere, but the same instrument can help plug smaller leaks too. A former Langley Research Center contractor founded Hedger Environmental in 2009 to use a carbon dioxide, CO2, sensor invented for satellites to monitor car emission instead. The emission detected and reporting system can be mounted on traffic signals and uses laser to sniff off the hydrocarbons emitted by vehicles passing underneath. Other systems are now deployed in 3 states and recently saw root use in Europe. Yeah, it is the advantages of the technologies, of course. And 16, guidelines to be applied to daily life on Earth. And this is just my recommendation. You can read, guys, an astronaut's guide to life on Earth. It's really good book. And the other, their contributions, the psychological and physical effect of Mars on people were best observed. There have been improvements in recycling systems for many biological wastes. Researchers on botany have done a lot of research on the mechanism of adaptation to harsh space conditions. This is the contribution. Evet, and 17, impact to sustainable development goals, SDG. Zero hunger, we have all of the end, zero hunger, good health and well-being, quality education, gender equality, clean water and sanitation. We have affordable and clean energy, responsible consumption and production, life on land, peace, justice, and strong institution, and partnership for the goals. We have all of the mission after that. And references, mine is the references. And also I put my references, I just try to put my all references in each page when it's necessary. And thanks you, contact me if there are any questions. Please contact me, guys, and my webpage, phone number, email address, and Instagram and LinkedIn. And also, I thank to Mars on Earth Project organization. The founder of the organization is Mr. Ruha Uslu. And also, I thank to Dr. Doğan Erhan Ersoy, PhD, for the advice about my seminar program, when I asked them a couple of questions about this stuff, those stuffs. And this is the organization between me and the Habitat Marte. And webpage is the marsonearthproject.org. And this is the phone number of the organization and email address and Instagram page and LinkedIn page. And I really, really thank to them. And I really thank to our professor, the manager of the Habitat Marte, the whole organization. And thank you, guys.